it's time for our next talk, and it sure looks like we are picking on every little thing that you can buy at Best Buy and plug into your network today, and that's awesome. That's awesome. So we're going to hear from the guys from Duo right now. We got Mark and Zach, and let's give them a big party track welcome. In fact, one of these guys is a new speaker, so that'll be fun.
We'll probably interrupt you. Yeah, no worries. Yep.
I missed party track, didn't I?
I don't know. I have no.
I think he was expecting his shot. Anyway, so welcome to the Internet of Fails, where IoT has gone wrong and how we're making it right. I'm Zach Lanier, Senior Security Researcher with Duo Security.
And I'm Mark Stanislav at Duo Security as well. Yay! Thank you. Thank you. So IoT, if you've been in this space for a while, you've probably more affectionately known similar things as M2M, so machine-to-machine. If you've been doing embedded security research, you're probably much more friendly with that term. I think cloud computing is a good example of how we all bitched about semantics for the first 5 years, and now everyone's just like, yeah, cloud computing, cool. But everyone wanted to be like, oh, that's not a thing, this is bullshit, and no one will ever do this. So I think IoT is the same way. Probably get past the definitions and the semantics of a lot of this stuff and kind of look at it for what it is, which is a huge sector, especially for InfoSec research. A lot of the talks I think we'll be seeing at DEF CON for many years to come will be around these kinds of devices. There's a lot to talk about today, so let's get on to it. In terms of what we have going, pervasiveness really is kind of where it comes down to. You think about home routers, right? You have the home router, hacking lab, all that going on. The number of devices that we have in IoT where you have firmware going, right? We can barely update one router. What makes us think we're going to update hundreds of devices in our household in 5 years? There's a lot going on there. The attack surface, whether it's a business or whether it's your personal life, right? You're going to bring the stuff in IoT into your offices. And if you do penetration testing, I'm guessing you're hoping people are going to bring these random things off the shelf at Best Buy that reverse proxy out into the office. That would be great for you. In terms of the overall environment, there's a lot going on just in terms of how diverse the technologies are. So the ecosystem is really messed up right now. You see companies, big and small, trying to standardize and make sense of it all, but really we don't see that quite yet, and I don't think we will for a while. Part of the cool thing about IoT right now and where we're at with a lot of technologies we'll talk about today is you can innovate really easily. You have a lot of agility, and IoT is really taking advantage of that right now. So how do you patch a bunch of firmware on the devices? Do you auto-update? Do you have people manually do it? What's that going to look like, again, when you're at scale? And then the problem we've always had with embedded hardware is you get random, ODMs, you have firmware that no one's actually done a security audit of, kernels that are 15 years old, and this is the kind of stuff that we're putting in our networks right now. So even though the device is new, the actual technology underlying it is probably not. Ecosystem overall. If you buy an IoT device, guess what? That IoT device probably has 3 or 4 services behind it from 3 or 4 other vendors. So you're not just buying a piece of hardware and putting it on your network. You're buying a piece of hardware, putting it on your network, and then it's calling out to 3 other services that then have data that you have for your device to function, or service accounts to make it tie into something else you're doing. So where does your data go when it goes to the IoT? It's the same problem as cloud, right? Where's my data at? With IoT, you definitely don't know where it's going. At least with cloud services, you at least know who, what provider might have it. With IoT, you're kind of just blindly trusting that the person that created that hardware has a good service provider on the back end. And like I mentioned, reverse proxy connections. If you haven't done this kind of research yet, you'll see a lot of devices traversing through all of your perimeter security, going out to the internet, and then exposing web interfaces on a public port through one of their service providers. So again, for attackers, this is kind of a big deal. Internet of Things, line of insanity, trademarked by me unofficially. So if you think about IoT and you think about attack surface, right? IP cameras seem crazy because they're a camera in your home recording you, audio, video, whatever. But really, that's kind of the purpose of this realm of technology. It's convenience. Yes, there's some risk, but at the same time, if I'm in Vegas, I can see my home right now, and that's pretty cool. If you go down the line, though, an egg tray that's connected tells you how soon your eggs are going to expire. That really kind of solidifies the insanity part of this for me, because imagine what company wants to be the company that gets breached by an egg tray in their office. We get really, really scared when fridges start sending spam. How about you actually have someone running code execution from your egg tray, or running Wireshark from an egg tray? That should scare you.
So one of the things that we've noticed is, so there is IoT. You're probably familiar with a lot of big commercial vendors who kind of occupy the IoT space, but lately there's been this explosion in terms of just anyone can buy any one of these things, like an electric imp. They don't even have to really understand hardware or software. They buy this thing, they solder some stuff maybe, or they get their friend to do it, and they go to this web-based IDE and they plug in some code, and then they get $800,000 on Kickstarter. So hardware is really, really cheap and very accessible, and the possibilities are endless here, and it's great because anyone can do this. But at the same time, any one of these pieces of hardware might have its own security-related idiosyncrasies. The people developing the software, the people running the services that back some of these pieces of hardware might not actually have any security experience or actually apply any controls whatsoever. So, the low barrier to entry is $25 to become a new IoT vendor. I don't know if any of you are familiar with some of the Wi-Fi enabled light bulbs, but this is one of the things that we started to think about. We actually have some Wi-Fi enabled light bulbs back in one of our offices, and you see something like Philips, which is a $60 Wi-Fi enabled light bulb, which you would assume, let's just all things being equal, Philips probably took into account some security measures, maybe. But then you have the $23 kind of Alibaba special that comes from who knows where, made by who knows who, and probably not as robust from a security standpoint. So if you were going to be deploying these light bulbs across your office so that you could maybe cut down on your electricity bill and automate some of the lighting, what are you going to pay for? Are you going to pay the $60 or go to this as low price point as you possibly can? So this is kind of, I think, really represents Mark's point about the IoT ecosystem. It's basically stacks all the way down, right? Just like with mobile, we've built on top of existing services and added in a whole new device running its own software stack with its own vulnerabilities and its own hardware issues. So have we done with IoT as well, because now we have mobile apps that control these devices and they talk to web services. So there's just this spaghetti of so security much connect.
So to point out, if this then that, we're not talking about vulns and their service or anything else, but we want to talk about kind of the principle that when you have all these embedded devices on your network, the next thing you want to do is connect them all, clearly. You want them to do cool things. And some of it's practical, right? Like my example here, you have a CO2 monitor. If all of a sudden CO2 goes up, aside from, of course, like alarms, maybe the light bulb turns red, or some other way that can actually, permeate your household or your office space to add value to what you already have deployed for technology. However, if you have 110 platforms and if this then that, what happens when they have tens of thousands of users and they get compromised? What does that mean for infrastructure, for businesses, for personal homes? What could you do if you had access to APIs? Maybe you found a vulnerability in one of the APIs that they're using for customers. What could that mean to people actually leveraging these platforms? So government, of course, at DEF CON is always a tricky topic. I think, though, if you've paid attention, the FTC is ideally there at all times to help consumers protect their interests, whether that's companies lying to you, that's companies saying that, oh yeah, we secure your stuff, don't worry about this. It turns out they don't use encryption or whatever else. So FTC has actually been pretty forward on this. They've had panels at CES. They have meetings talking to different people in this space. But TrendNet, which we'll talk about an example here in a second, that was actually a case where they came down pretty hard on TrendNet because they had a vulnerable IP camera with a pathetic vulnerability that should never get out the door from any respectable business, and it put a lot of people in danger. So. For better or for worse, there is government oversight in this space. And so the people in this room, like, you don't want to be left behind. If the government's ahead of you in technology, we've got a problem. So think about what you're working on. That would definitely set a precedent.
So just to kind of give an overview of some of the challenges that small vendors in particular face, and large vendors as well when it comes to IoT, we'll just kind of run through some of these. So even obviously the talk that preceded ours, and many of the talks that will probably happen throughout this entire conference, and I'm sure none of you are strangers to this, but hardware security is kind of can be a death knell for a lot of these devices. And as we showed with the $25 to $130 devices that are out there, a lot of these devices that are out in production use just sort of generic system on chips or development boards, and they're designed to basically facilitate rapid prototyping, quick development. They don't really have a lot of security features for a variety of reasons. Maybe they just want to make it as agile as possible. They want to make it as quick as possible. They want to have low power consumption. They any number of things. And another thing that can be overlooked is the prevalence of the same components. If they're using the same SoC, or if they're using the same microcode, or any number of things, finding one issue in one of those things could affect a whole swath of devices that it might not even be by the same vendor. Like we said, there's almost no expertise required to really become an IoT vendor at this point. So the kind of least common denominator this is, I'm not really a great hardware hacker, but this is cropped up time and time again, is literally like these devices getting shipped out in production with things as simple as UART headers still exposed, and you just drop right to a root shell on one of these devices and you start stealing all the things, and then you go and repeat that on every other single one of those devices. Software security is still a big issue here as well, because a lot of the environments that, electric imp in particular, or as an example, you're kind of restricted as to what language you can actually develop in. So that might, people might not necessarily, if it's something like a really low end or really great embedded device, you might have to learn C, and people continue to fuck up and not learn C correctly. So they do things like use functions that they're not supposed to, right? There's dangerous behavior repeating itself because me write C pretty one day. So it's just sort of history repeating. And then because you might be picking a platform that restricts your language, you might be also restricted to what operating system you can run as well. And if it's an operating, if the OS is already loaded there, or you're using some vendor-provided OS, they might not have taken into account simple things like exploit mitigations. They might not have even done things like, DEP, ASLR, or NX or XN. They might not be doing any sort of linker, mitigations. Nothing. So even just an example over here from an embedded device. Which actually runs a web server that talks to a bunch of other things that are really important. There's pretty much zero memory address randomization. So the dependency on other libraries, if you think about things like Heartbleed, for instance, relying on these other opaque or even open source libraries, you basically get this bug inheritance as well. And this applies to mobile applications that run these things as well. So communications and network security for a lot of these devices, there might be some really weird goofiness. I know someone in the audience is going to recognize this example, but when the device actually acts as an access point, or it connects to a remote control that then controls it. It can act in either mode, when they don't necessarily enable things like even WEP or even WPA or WPA2, or they just have some other exploitable behavior. There are cases where they will transmit things like software updates over plain text, or if they do transmit them securely or over SSL or TLS, they don't sign the firmware update blobs or anything like that. Numerous services that are exposed on a lot of these devices that don't necessarily enhance functionality in any way, so just remote administration services. Shared accounts are a problem as well, wherein they might the vendor might provide a support account for updates or remote support, and maybe there's a static SSH key shared across all of these devices, or the same hard-coded password, or things of that nature. And then these are complicated even furthermore by use of other technologies like 6LoWPAN, Zigbee, etc. And then the simple example where you can go and spend, I think, $50 and plug a GSM modem onto your device. And there are talks here that will discuss yet again how ridiculous GSM is. So comm security is still a really, really, really hard thing to solve, apparently, when you're a small IoT vendor.
Kind of getting back to the fact that the IoT device you have really is not just an IoT device, right? It's really just kind of a hub for a bunch of services that are then going to connect to it from like 4 or 5 third-party vendors. So if you think of things like APIs, APIs rarely are actually APIs. They're just like, oh, I did a GET against a web server, therefore API. And what we're seeing, what we're not seeing, authentication against these devices is rarely there. It just will say, oh, well, this is embedded hardware. Clearly, you can't see what these calls are over a network, and have no protection on them because they think no one's going to look at this kind of stuff, or signing requests to ensure integrity to what API calls you're making in the first place. So OWASP, mobile, web top 10. This is all alive and well in the world of IoT. The same problems that we all attack online and the internet, guess what? They're all in these IoT devices as well. So if you're looking to get a shell on one of these devices, maybe it has a SQL server, because why not add a SQL server to everything? And maybe it has a web app with poor code handling. Well, guess what? Now you write your PHP shell or CGI app, you drop it on that IoT device, and now you have CNC over this entire network of IoT devices in that home. So just kind of conflating all these different technologies that we already screw up really badly all the time. Now it's just like this magical box of terribleness, and that's what you're buying for $150. So the third-party providers thing, I've seen those go really badly. We'll talk a little bit about that today, but not too much. If you think about cloud infrastructure and the services that people stand up, whether it's a PaaS or they're doing infrastructure in like EC2 or something, a lot of these cases, they might understand how to get the software out, which probably isn't true, but they at least know how to get a nice piece of hardware out. And then they're saying, oh, well, we need all this infrastructure now to support this. Well, they're going to have infrastructure vulnerabilities. They're going to have, OSs they didn't patch. They're going to have, default credentials to web app services and everything else that people do wrong already. Now you're going to have that across 4 or 5 vendors. Kind of getting back to what I started on, which is this idea where it's hard enough to get people to update their routers, but at the level of coverage in IoT that I think we'll see in the next few years, that's going to be a really big problem for most consumers out there. This audience is exempt. You guys will upgrade your firmware, hopefully. But if you have all these different examples across your life in technology, that some things you bootstrap by opening the mobile app and saying like, oh, new firmware version, hit to update. And then some of them you hold a button on the back of the thing to call home and bootstrap to that process. And some of them you go to the web interface on the device, the web interface that was mentioned once in the instruction booklet that you threw promptly away. So there's all these different ways to do firmware, and one thing we're not seeing very commonly is auto updating firmware. Now you can make pros and cons to whether you should auto-update firmware. Certainly for the vendor, it's a lot harder of a process to get right and have recovery mode and all that. But again, how many of these are we going to have, and what's that going to look like if one bug comes out? If another Heartbleed happens in 5 years, what would that mean to all these devices that have SSL stacks that are compromised now? So let's jump into some failures. We're going to kind of start it. So a lot of this section of the talk is really an anti-pattern talk. What happened, why it's wrong, how you should be doing it right, because I think that's a pretty good methodology to help people understand what's going on. So the trend that I mentioned earlier, basically they had a CGI app on this thing where it was viewing video, and don't let the /anani part fool you. That's not supposed to be an anonymous endpoint for this thing. They actually just failed at, I think it was a code regression on some of their firmware that was across dozens of their cameras. And in this case, the first time this bug came out, someone actually indexed 700 cameras almost immediately, put them online. They actually created a Twitter account to say like, oh, look, a new camera that's vulnerable to this. And you could just watch the video stream by just going to this URL on any IP you could find off Shodan or Google. So kind of a big risk for people that bought this camera thinking like, yeah, TrendNet, legit company, they've been around for a while. In this case, this is all you do. You go to Google, do in URL, and find some cameras. And that's, of course, if you don't just go to one of the many aggregation sites for big creepers. But don't be a big creeper. And really what frustrates me, this isn't a security thing, right? This is like basic QA 101. does your admin have access to admin pages? Do your guests have access to guest pages? And can your guests get to admin pages? The answer should be no. And they didn't take the time to like run a curl script on a loop or Selenium test or anything else that would have very quickly caught that this was a problem. So second one, IOActive has done, always does amazing research. One section they did a little while back was on some of the Belkin Wemo stuff. In this case, you have Belkin, which is actually doing some of the best practices out there. They're actually signing firmware. Unfortunately, and anyone who's ever got a key burn knows how this feels. They had the key and the passphrase actually hard-coded in the firmware. So the firmware got dumped. They extracted the signing key and passphrase, and now they're at a point as an attacker where you could actually sign valid firmware. So if you can man in the middle the update request, or you can somehow otherwise interface into the update mechanism, at that point you would actually be able to push valid firmware onto that device. So, TLDR on this one, and we're gonna, I think, touch this one or two more times while we're standing up here. Don't hide stuff in firmware. It's not hidden. Like, whether someone gets the firmware today or tomorrow, whether you think that you like obfuscated a key in there, you didn't, it's not hidden. The same thing applies to mobile apps. Just because it's encrypted when it goes up to the App Store does not mean someone can't just dump memory and get all the ASCII out of that binary and go through it.
So the context security was looking at these LifeX devices, and what they discovered is that so 6LoWPAN, another low power, IPv6 over this low power mesh network. Inside of the device, once again, hard-coded symmetric key for encrypting all sorts of data, including credentials, Wi-Fi passphrases and such for the other side of this device. So the hypothetical exploit, you give this to someone as a gift. You creep up on their house per usual, and once they add the bulb to their network, you just capture traffic, decrypt it with symmetric key, and then you get all their Wi-Fi credentials, and then you just jump onto their Wi-Fi network, and you creep on them there as well. So again, repeating the same exact thing from before. Don't hard code things if you don't want them to be found. They will be found. So that's why Gooby and Dolan are over there. So another example here. This is a home automation gateway that was built by a large utility, provided by a large utility provider. What they did was they actually outsourced all this to another service provider who gives these basically like white label devices that connect to their infrastructure, so that you can go on there and have your lights flip on and off, have your pool pump flip on and off, and automate it all through this beautiful web interface. It's really ugly. It wasn't that beautiful. It can be controlled through a mobile app as well. So you talk to this magical cloud site, and then it over this reverse connection to this gateway will push down directives from the user, scheduling information, things of that nature. So this is kind of represents sort of the whole swath of things that the web interface itself was vulnerable to all sorts of OWASP web top 10 101 things. And then the gateway itself had unfettered console access. There were URL headers exposed that dumped you right into a root shell. There was no privilege separation for any services on the device. The same support credentials were used to manage all of these devices. And then on the other side, on the Zigbee side of it, where it talked to the controllers, it was vulnerable to things like key extraction, replay, injection, etc. So this is sort of an example of we start to kind of encroach upon utility and more ICS type stuff.
Cool. So that's some pretty cool stuff that other people had squared away in this space. So this next topic is something I actually did last year. Does anyone have or had an eyes-on IP camera? There's plenty of people, and there's got to be one or two. Yeah. Did you get rid of it? It's not surprising. A couple examples. So IP camera, I bought it. I had the best of intentions. I happened to scan my network one day, as you do, and there was Telnet listening. And whenever Telnet's listening, in 2013 at this time, you should just stop what you're doing, figure out why Telnet's on your network, and stop it immediately. So into trying to break into this device and do bad things to it, one thing I did, getting back to my don't hard code stuff anywhere, is Okay, all right. Set up. So the mobile app in this case, again, people assume mobile apps safe, they're encrypted. Well, when you have them in your phone and you start them, guess what? They decrypt. So you dump memory and you get the decrypted version of this. And in this case, in this IDA screenshot, this was actually shell scripting that connected over Telnet to do the firmware upgrade kickoff. So you have hard-coded root credentials over Telnet firmware upgrade. This is what we're talking about in IoT and the Internet of Fails. Like that, this is like a collapsing of terribleness. So in this case, run strings, get some details, drop your admin credentials, and log in. And now you, guess what, have access to root on every single camera because this is in the mobile app. This isn't a one-off thing. This is every single one.
All right, let's congratulate our first-time speaker to DEF CON.
Thanks, Bruce.
Cheers.
Oh, there you go. Oh, I feel so much better now.
I just want to point out, I love that Internet of Fail comment about the Internet of Things.
Is there anything different? Isn't that just a synonym?
Well, it's true. It's where we've been for ages.
So if you are ever in charge of this scenario, do not use Telnet. If you do, you're not at DEF CON, so let's face it, your guys are fine. And don't hardcode passwords. Another example, and this gets to the service layer. So Amazon Web Services was being used to actually store the video recording. So if you had an alert, like a motion alert, sound alert, it would record it, drop it to S3. Your mobile app would then go, hey, I need to see that alert, and then it would pull it up. So in this case, there was no authentication required to hit the endpoints for S3. So they weren't using IAM or any of the other very smart ways you should do things. The files were protected with MD5 strings, probably for the actual file digest. And there was no SSL. So A, if you're in a coffee shop and someone's on the network, guess what? They're going to see the same video you're watching on your phone. B, if you have a shit ton of time and a cluster and want to piss off AWS, you could probably get through a little bit of key space and maybe find a video or two. But it's one of those things, you take something as simple as upload a video and store it. They don't encrypt it. In transit, they don't encrypt it at rest, and they don't actually protect it with anything more than just a file name, unique file name string. So if you thought your video of you getting out of the shower and walking by was going to be deleted off the internet securely, I wouldn't hold hope out. So yeah, simple things like AWS has identity access management. It's very easy. You can give credentials per user, block things off, put it in the mobile app, make it connect out and actually do API calls the right way, and segment data. Also, hey, Amazon, you could actually just encrypt before you upload. Simple as that. And yes, good. Cat video is cat videoing. So you guys enjoy that for a second? Okay. Getting back to my tirade against APIs. Is it the always poorly implemented or is the lulsec? Okay. So API calls, in this case, the API calls that were actually going out, again, without SSL, because why would you encrypt anything? And the secret token in the API call, this is how you can tell always poorly implemented is true. The secret token was just the user's password that was MD5'd. So if you didn't already have their password and you were on the network with them, you sniff, rainbow table that, crack it because they were going to be a terrible password anyways, and now you can just log in as that person and look at all of their video real time and see them when they're getting out of the shower. One thing that happened here which really pissed me off, and I made that very clear to the vendor, is they actually took my password that I signed up with for their service and transmitted the MD5 sum to their vendor, and they thought that was like okay to do. So when we do things like use 1Password or LastPass or Dashlane or whatever, and we're like, yeah, we have 1Password per site, guess what? I didn't know that this was a vendor. So if they get breached, I'm not like changing my password because I don't think I'm impacted. But I am, because they've passed my password on to someone else without telling me about it. So I think one thing that helps is looking at kind of the big picture of what's happening in IoT. Remember, this is one device. All of those things that you're seeing on the screen are either a direct vulnerability I found, just a terrible failure of best practices, or just a total compromise of security for all customers. To the point where they actually had hard-coded Amazon S3 credentials in the mobile app. Remember how I was just saying that Amazon S3 was the place they stored everyone's videos without any kind of segmentation?
So we're supposed to say that this vendor is redacted, but yeah, whatever. So these are real issues that we identified maybe six or 7 months ago, almost, well, even longer. Basically, just to kind of give you an idea, this device is basically a little embedded device. There's a mobile app that goes with it, and you can pretty much control everything through this mobile app, and it talks to AWS and pushes messages back and forth and down, and uses electric imp for the hardware platform, so do your homework. So the session IDs for to talk to their service to actually manage and push messages down to this device were just based on Unix epoch, period. It was just the Unix epoch as timestamp for when you logged into that service. So that it's a very small space in which to actually brute, right? So enumerate all the recent timestamps, just brute force through them. So you then become a user simply with this little browser header. So clearly the fix is use real session management, right? This is all back to top 10 OWASP 101 basic web security stuff. And by the way, the impact here is pretty bad because it has to do with kids. So, they also have a system where you can buy credits to then send messages to these various devices. So you would purchase these credits via in-app purchasing inside of the mobile application. Now, as it turns out that it was client-side enforcement, basically. Like the client would tell the server how many credits it wanted. So the server was like, yeah, cool, whatever you say. So you could just basically pick a number, any number, signed integer, add and remove credits as you felt fit. So you get that many whatever credit things this gives you. So obviously, do not let the client be the authority for this, because you must assume that it is in the bad creeper's control. Excuse me. So there was also this sort of not really a confused deputy problem, but just basically a major fuck up where the analogy here is if you are using something like Facebook, I send you a friend request, you have to then accept or reject that friend request before we see each other's stuff, right? Technically, like that's generally how it works. Here, however, you could ask the user or whoever your target is to be your friend and immediately access their stuff. So you could start sending messages to this device. So, ask user to be your friend. You get some stuff back about the user, and then you can just start sending messages to their device. So, obviously, have a real authorization process for all of these things, and don't actually transmit anything about the target back that the attacker could then use. Actually have that control be on the target's side. And then, of course, there is the heartbleed discussion that doesn't seem to want to die. So you've got mobile apps speaking to embedded devices. You've got embedded devices speaking to remote services and back and forth. There's been these stats. I think it was something like 300,000 services have still been identified live out on the internet that are vulnerable to heartbleed, probably other things as well. But you have to ask yourself, what about these devices that are deployed internally, or the services that they're talking to, or even the clients? Are the clients actually vulnerable to heartbleed? Obviously, that's been demonstrated as well. So you really think that the $60 or $25 Alibaba special light bulb that you bought, if that happens to be vulnerable to something like this, do you really think that you're going to actually get that addressed, that the vendor actually cares? It might even be a fly-by-night operation. So, or may not have the expertise to deal with this.
So one problem that we're seeing and why we're so interested in this space and trying to make it suck less is the vendors that you're going to see in this space are not the Belkins, obviously they have some stuff, Cisco has some stuff, but they're not the people that you're going to get most of your devices from. A lot of the stuff, if you look at Kickstarter, Indiegogo, Dragon Innovation, there's a lot of IoT crowdfunding right now, and if you think of like 80 grand, you have to do R&D, prototyping, software development, hardware management, cloud services, hire marketing and sales people, build devices, ship them, and then have like legal, right? $80,000 is going to go very, very, very quickly. They're not going to have money to spend on protecting your device. And they're again, everyone has the best of intentions, right? And that's why this road is paved, to hell with IoT devices all along the way. We're going to be in a really bad place, much worse than we are now, which is already pretty bad. And if you look at postscapes.com or devices.wolframalpha.com, go see how many companies you've ever heard of, because they're probably brand new entrepreneurs, brand new bootstrap startups, or someone that crowdfunded a device. And this is the kind of stuff all of us are going to want to buy, but at what cost, right? One other main point to this is a security researcher to Belkin or Cisco or Samsung at least means something, right? They're like, oh, security research, okay. These vendors with 2 people on staff that are both maybe one product designer and one guy that's okay at mobile apps, they don't know what security research is. They probably don't come to DEF CON, and they're going to be the people that are trying to triage bugs and thinking that you're breaking into their company and trying to extort them. And we've been told on a call by a lawyer that we hacked their systems and that we were doing terrible things to their company, when all we were doing was testing the device locally in our home. So. Crowdfunding, again, a lot of this is coming out of crowdfunding. It's not just speaking in platitudes, literally some of these devices are that you might be using right now actually were probably crowdfunded. And it's a great way to innovate for sure. But again, the margins on these things are nil, and the amount of extra capital they have to invest is also nil. So it doesn't really turn out too well.
So kind of back to what Mark was just saying a minute ago, a lot of these small vendors, and we've had this experience time and time again, as I'm sure many of you probably have as well. These small vendors, even some large ones, even to this day, right? That's why we still have CFA reform, shit like that. They don't quite get why you're coming to them telling them that their baby is ugly. So why would anyone want to hack my device? What are you selling? Why would you want to talk about this publicly? They don't have the resources or the experience to necessarily deal with this. Like Mark said, they might be strapped for cash, or they're just trying to get the product out the door. So the nascency of this space as well means that certain researchers, even if you're badass, super mega cool exploit dev, but haven't really ever interacted with an IoT vendor before, especially one of these smaller ones, you might not know how to approach them. So we'd kind of like to bridge that gap between, much like other initiatives I've done before for the traditional space. We'd kind of like to make sure that stuff gets fixed and that you all stay out of jail when it comes to IoT.
So born out of some of that redacted slides you saw and just general frustration talking to vendors in this space and realizing that they're not going to get it, we started an initiative called Build It Securely. So primarily we're focused on the small company, like the vendor that is Kickstartered or is bootstrapped, because more often than not entirely, but more often than not, they're going to have no money. Even some of the big vendors don't actually have as many security resources on staff as you would like to know or like to think. And so primarily we're looking at trying to bridge that gap for them and help them get better devices in your hands. So we're going to still do research. You're going to get devices you don't have to throw away after 2 days. That's pretty cool. We're also trying to curate resources on the site. So if you want to know, hey, I'm an engineer, what's the one doc I should look at for iOS security? What's the one REST API presentation I should look at? And we'll try to curate some of those on the site and just give resources that we think are pretty legit, and hopefully they actually read them and go through them. And then, of course, presenting at conferences like this to talk about this and getting people involved. So it's been a long road. We'll look at a timeline in a second, but where we're at now is so Dropcam just got acquired by Nest for $555 million, unrelated to our impact on them, I assure you. At least I haven't got a check cut yet. And Belkin just came on, so obviously we talked earlier about IOActive and Belkin's research. Brian over at Belkin actually has really, really good security pedigree, and he really does want to make things better. So we're going to be working with his team as well to give them some extra resources to make things more secure for all the cool stuff they have coming out. DipJar is actually a incubator startup out of Boston. And they're doing some cool stuff with basically a tip jar, GSM enabled, that you can just dip your card in, and that's how you tip people if you don't have cash and you want to just kind of go and say, here's $2. And who else do we have? Pinocchio, which is actually a system-on-chip vendor. You might have saw them in earlier slides. Zendo is a stealth startup right now in the IoT space. They're going to have a pretty large product line coming out here. Fun fact, the CEO of Zendo is actually the former CEO of STEM Innovation who made the eyes-on camera. He saw my research previously, and at this new company, he doesn't want to do it the wrong way. So we get really cynical about companies not giving a shit, but I had a cold call from a CEO of someone I burned in the news, and he reached out to me to have me come in and give security lectures to his engineering staff. So it's not all like doom and gloom as much as we might pretend. There are companies that are trying to work hard on security, and we should try to support them. So amazing researchers, IOActive, Stephen Ridley, Stefan Chenette, Don Bailey, NCC Group as a whole. Did we forget anyone? Zach and me being jerks. And then BugCrowd is providing their entire platform pro bono to us so that researchers can triage bugs to vendors through a private communication between them. And the best part about all of this is all the researchers are basically doing this, one, because they want to help some people, two, because they're going to get research done and not be sued for it. They already have opt-in from these vendors. So, these are some pretty awesome companies, some companies you might not have heard of up here, but these are really interesting companies doing some pretty impressive product lines coming out in this space. And we're going to have researchers looking at pre-production hardware, doing assessments against them, getting them bugs, and actually making these devices better before they go into people's hands rather than after. But again, they'll be at DEF CON hopefully next year talking to you about some of the stuff they broke because that's part of the deal. And in terms of timeline, we just started this up in February at B-Side San Francisco. We've really been kind of spinning things up pretty slowly. We don't want to have a situation where we say like, oh yeah, every researcher on Earth get involved in this. Like we're not trying to, have the largest list of people. We're trying to have the most output and the most production. And sometimes you have to kind of, do the walk before you run. So far, so good. We actually just in July shipped hardware from Pinocchio to 2 of our researchers. So that's kind of our first, line in the sand that, hey, we accomplished something we were trying to accomplish. And we have a lot more coming out for the next few months. And we'll be bringing more researchers on. We have contact details at the end if you want to look at some of that. But Pinocchio's got the hardware, BugCrowd set up for our vendors at this point. We're still kind of doing some of the stuff that we all deal with already, which is like timelines, triage, when do bugs have to get fixed, when are we going to drop bugs, and just some of the stuff that any kind of coordinated disclosure goes through when you do this sort of process. And we're growing. It's not about, again, it's not about having the most people on our website. It's about having the most people getting shit done and associated with us, which is something that our vendors have taken kindly to. They don't want to have you throwing 300 people at them because it's hard for vendors that don't have security in-house to understand how to work with vendors. So we're actually doing a lot of knowledge transfer and teaching vendors in this space what security research is, how it works, why people do it, why we're at DEF CON in the first place, right?
So what does it all mean? What's the conclusion? So basically what we've learned is that people can actually be altruistic occasionally. There is a lot of cynicism, but sometimes people can suspend that or actually erase it entirely. And don't be afraid to actually reach out to people, and vice versa. Don't be afraid to. We encourage collaboration. We want people to want to do this. We want this to be a community effort. So we can actually have an impact, and that's why we've partnered with I Am the Cavalry, for instance, because this kind of falls in line with some of the stuff that they're doing, and it gets us visibility and gets them resources. So, of course, we did have some aggressive goals initially, but we stepped back and kind of just made it a little more comfortable. We doubled the timeline basically, and since these people a lot of the researchers are doing this. Pro bono, they're doing this, of course they get the added benefit of maybe business, but they're doing it for us pro bono. They're pretty busy. They have day jobs, so do we. So this is also us, kind of taking spare cycles and working on this project. And again, like Mark said, we want quality, not quantity. We want more people to be involved, but we want to make sure that everyone's kind of on the same page and that, everyone's going to be able to relax into this. And then measured successes and milestones. I mean, so far we've done pretty well in at least hitting some pretty significant milestones. They might not seem significant to a lot of people or in the grand scheme of things, but it's definitely accelerating us toward where we want to be. So IoT is still malleable enough. This is still a nascent enough space that we can actually have an impact versus some other spaces like Web security has been solved or some shit, but we're not having to like kind of shoehorn all these fixes into everything else. IoT, we can actually kind of make a difference now before it becomes catastrophic. This could also help consumers make better decisions as well if they see not really so much an underwriter's laboratory type thing, but maybe something similar. It would at least give consumers a sort of a yardstick to say, oh, well, this has been vetted. This vendor clearly cares, and people can kind of decide with their wallets, right? So we figured that if nothing else, and this goes completely haywire, we at least helped a few vendors. We at least got some researchers to do some cool stuff, and at the end of the day, that's not bad. So the site is builditsecure.ly. You can also reach, there's a mailing list, which I think we actually didn't mention. The mailing list, the thing about that is we have both our vendors, our partners, and the researchers all on the same mailing list. So there's no siloization of everyone, like, let's talk bad about this vendor over here. It's created a very nice open communication medium where if there's a question, somebody says, I'm going to be deploying firmware XYZ soon. Does anyone want to help me test it? That happens just universally. There's no siloization whatsoever. The Twitter account is at Build It Securely, and of course, Mark and I can be reached at these two, duo email addresses, and you can stalk us on Twitter. So with that, I think we have a couple minutes left. If there are any questions, otherwise, you can meet us in the chill out lounge afterwards. And thanks.
Thanks, guys.